In this presentation, we're going to take a look at a binary search, what it is, how it works, and what we can and can't do with one. To begin with, in a binary search, there are certain parameters that must be obeyed. First up, it will only work with a sorted list. It doesn't work with unsorted lists, so don't even try. If you don't have a sorted list, it will not be able to find a value, and it will just need to check every single value as you work through. The aim of a binary search is to find a value in a list, and the search stops when it finds the first match, even if there are more. If it's not found, the search returns either a not found value or a null value. It depends on the algorithm you're dealing with. When you look at the algorithm, this algorithm I'll show you is in three parts. The first one is the initialization. In this in this algorithm, please note the numbers to the left are there for your reference only. They are not part of the algorithm. So this initialization sets the lower value to the first position in the array, so the first index value of the array. Line 40 sets the upper value to the last position in the array, sets foundIt, which is the Boolean value, to false. FoundIt is false, so therefore it will continue to run the algorithm. And it will find a target name, which is the value we're searching for, and that's the setup of the algorithm. Now in the second part, this is quite complicated, but it's actually quite simple. Again, the numbering continues from the previous. It's saying calculate the middle position. Now the first thing we'll notice about that calculate the middle position, it is a subroutine. The underline defines a subroutine. We'll come to that in just a moment. Lines 100 to 120 work out what happens when target is found. Note that this will only find target once. If set founded to true, set position found to middle. In other words, set the position found to that value, that index value. Lines 130 to 150 will find out what happens if target is less than middle. In this case, it sets the high value to the value 1 index lower. If target is less than data at middle value, set the upper value to middle minus 1, to 1 index value lower. Otherwise, set the lower value to the middle index plus 1. And it will repeat that until foundIt is lower, or foundIt or lower is greater than upper, and then it will return a position value for yes or no, it found it, or no, it didn't find it. The algorithm for calculate the middle position is upper plus lower divided by 2, and it sets the middle to the integer value of that middle part. Now if there's an 8 value array, upper plus lower is 1 plus 8, which equals 9, divided by 2, which is 4.5, and it's the middle integer value of middle, so 4. End program to calculate middle position. Notice that if you have a 9 value array, 1 plus 9 equals 10, and the middle value there would be 5. If you had a 10 value array, 1 plus 10 equals 11. Half of that is 5.5, would again still be 5. Now let's look at a different way of running this search. This is now without using the subroutine, and this is the value that, or the algorithm that comes up in the syllabus and also in your textbook. Let middle equal upper plus lower slash 2, again integer part of middle, so that will always do that as part of the repeat, work out the upper value, lower value, and get the middle point of it. It still works the same way. So when we look in at let middle equal upper plus lower, let middle equal integer part, required name, then let foundIt equal true. So if we're looking for a value in middle, the index value of middle, if it's true, fantastic. Otherwise, if required name is less than the middle value, let the upper equal 1 lower than middle, let the lower equal 1 more than the middle, until it's found. Otherwise it will return found or not found. Let's do this as an example. So the top row we have 1 through 8 for our for our index array, and we have assorted values 12 through 45. Notice that this list is still sorted. The target value is that one, 24. So as the algorithm starts, we know the lower value, we know the upper value, and from that we calculate the middle value, which is 4. 1 plus 8 equals 9, divided by 2 equals 4.5. Integer value of 4.5 is 4. There's middle. Now we're looking for 24, so straight away the algorithm says I can wipe out that part of the array. So therefore now I have a new lower value, a new middle value, and my upper value hasn't changed. Once again, we're looking for my target of 24. I haven't found it yet, so I wipe out that part of the array. I have a new upper value, a new middle value. I've found my value there, I've found my value there, and hey presto, there is my response. Piece of cake.